Hello and welcome to the Topic 3 Part 2 lecture. This is all about ionic naming and formula writing. I can only stress to you so much. It's so important that you are able to correctly write formulas and name compounds. The College Board exam will require you to do this all over the place. It's just expected that this is the language that you speak. So this video is all about ionic naming and formula writing, and then there are other videos about molecular acids and organic naming and formula writing. So this is the beginning now of when it really starts to feel like chemistry. It also should be review for you from your first year chemistry class. Depending on how much you had to memorize, there will be a fair amount of work to memorize at this point. So make sure that you're working at that and that you're working to be really careful, that if you make a mistake, you take careful note of that and you work really hard not to make the same type of mistake again. So let's see what happens. As usual, you should already have learning targets in your notebook. So please make sure that if you haven't done so, you stop the video and take care of them first. And here goes. So ionic naming and formula writing, the thing that you need to be able to do is no one's going to say to you, this is an ionic compound. You have to know that you're using this set of rules, and you have to be able to identify that from the fact that it will be a metal and a nonmetal or a metal and a polyatomic ion in the compound. The only exception to this is that you might see ammonium at the start of the compound. That's NH4. It is clearly a polyatomic ion. Remember, anytime that you have a polyatomic ion in your compound, it is going to be an ionic compound. So you're looking for those things to make sure that you know what you're doing. Naming is not so hard. You're going to name the cation, which is the positive ion and always written first. The decision that you have to make is whether or not it gets a Roman numeral. So if you already know the charge, that would be from group 1A, group 2A, and then aluminum, zinc, cadmium, and silver, then there's no Roman numeral put in the name. These are the ions that are positive that you should know the charges of. If it's a different metal than what's listed there, then it's going to have a Roman numeral to tell you the charge, and you need to include it when you name it. We're going to take the second half and name it based on whether it's monatomic, one atom, or polyatomic. If it's a polyatomic, you're going to use the name that you've memorized, and if it's monatomic, you're going to change the ending to "ide," like Cl would become chloride. Okay? Writing formulas, you have to be super careful about charge balancing. So the easiest way to know that you're going to be right when you do this would be to write the formula and the charge of the cation and of the anion. Balance the charges by figuring out how many of each you need. In first year chem, you might have been taught to crisscross those charges down, but I really want you to be thinking about how many of each will it take to make this overall neutral, and use your subscripts to show that. If you need more than one of a polyatomic ion, you're going to use parentheses to reflect that. That's the only time you need parentheses. And Roman numerals never go in formulas, only in names. There's a fair amount of memorization. So this is on your what to memorize list. You need to memorize the positive ion charges of group 1 and 2A, and the negative ion charges of group 5A, 6A, and 7A, down to the stair steps. And then you should memorize these 4 ion charges of transitions and post-transitions. Any other transition or post-transition metal will get a Roman numeral in the name, so you don't need to memorize any charges. Your book talks about the old system using cupric and cuprous for copper 2 and copper 1, or ferric and ferrous for iron 3 and iron 2. That required more memorization, and you're not responsible for that. So we use what we call the stock system, which is the Roman numerals. Also, you have a polyatomic ion list to memorize. If you had me the first time around, this is the same list. If you had a different teacher or you weren't required to memorize them, then you must make sure that you memorize these. This is going to be really important. There may be a few others that you encounter throughout the year, but these are the ones that College Board really uses. All right, the last thing I want to talk about before we just do some practice is hydrates, which are compounds, ionic compounds, that when the crystals are formed, they're formed from a solution. So in other words, we evaporate the water out of a solution and the crystals are left behind. When that happens, some of the water of solution gets trapped in the spaces between the ions in the crystal. And so we call them hydrates. I really like this image because this is copper 2 sulfate pentahydrate. Now what you're seeing here is only 3 waters, so it's not complete when you're looking at one formula unit here. But when you look down here, you can see that we have, it's hard to find them, but we have, here's a copper. Notice that the copper is in the center here, okay? So we want to be paying attention to the idea that this is the copper in the center. And then we have this as a sulfate, okay? So copper 2 sulfate anhydrous would be missing those 3 waters. So let's see what we can find. Here's the copper, and oh, I had to choose one that didn't have a sulfate attached. So hang on. Here's a sulfate, SO4 2 minus. And then we see attached to it a water right here. And then here's a copper that has 4 waters attached, right? So it's hard to see them all, but basically what happens is that we end up with 5 waters attracted to these ions. You should notice that the copper ion has the positive side. The positive ion has the negative side, of the water attracted to it. And then you would expect that the sulfate would have water like this attracted to it. So when we find one, they're really hard to see in the middle. But when we find one, it's here. And here are the hydrogen ends attracted to that sulfate, okay? So this is really hard to see, but I did want you to see that there's lots and lots of empty space in these crystals, and they would definitely be filled with those waters attracted in there, okay? So when we write the formulas for hydrates, we write them with a dot in the middle to reflect the number of water. This is something that's going to be consistent based on who the compound is. So it's not like you have to make this up. Someone will tell you. You're not expected to memorize who does what, but copper 2 sulfate pentahydrate would be CuSO4 dot 5H2O. That dot does not represent multiplication. Rather, it tells us that the water molecules are physically a part of the compound. So this is a compound and this is a compound, but the 5 water stuck inside that crystal is a physical change. All you have to do is evaporate the water out, okay? And if you're going to calculate the mass, you would have to add up copper at 63.55 and a sulfur at 32.07 and 4 water at 16, and that would be the CuSO4 part. And then the 5 water part, water is 18.02 by the time you add 2 hydrogens and oxygens, and that would be for the water part. Okay, so you'd have to keep that in mind. And naming it, you're going to name the ionic part, and then you're going to use a Greek prefix to tell me how many waters are trapped inside. And so this would be, you can see the pattern. Copper 2 sulfate pentahydrate would tell me 5 water inside the crystals. So this is your review now, and let's go ahead and start to practice. All right, so I'm going to take this information and we're going to decide what the name of the compound would be and then write the formulas as well. So using a periodic table, I can look to see that zinc is going to be 2+, and oxygen is going to be 2-. And so I have Zn2+ and O2-. Those charges already match. So this would be ZnO, and I'm going to call it zinc. I don't need a Roman numeral because I could tell the charge from the periodic table. Oxide. Ide instead of oxygen because it's a monatomic anion. Bromine and silver. Bromine is a nonmetal and silver is a metal. So I'm going to always write these with the metal first. So silver is Ag, and from the periodic table, I should memorize that it's 1 plus. And bromine is Br, and from the periodic table, it's 1 minus. The charges match again, so this would be AgBr, and the name would simply be silver, no Roman numeral, bromide. Lithium and chlorine. Lithium is in group 1, so it's Li1 plus. Chlorine is in the same group as bromine, so it's Cl1 minus, and this would be LiCl, and lithium, again, no Roman numeral, chloride. And then finally, sulfur and aluminum. Sulfur is here as 2 minus, and aluminum I should know as 3 plus. I'm going to put the positive one first, so that would be Al3 plus and S2 minus. Finally, the charges are not balanced. So my least common multiple between 3 and 2 is 6, which means I need to put 2 aluminum and 3 sulfur to get a total of 6 plus and 6 minus. But the name is still simply aluminum sulfide. You're not telling me how many in here. I can figure that out from those ions. Okay. I'm going to ask you to stop the video here and try these yourself and then restart it to check them. Okay. So really quickly, this would be K1 plus and S2 minus, which is K2S, and potassium sulfide. And then iodine and barium, the barium is the metal, and it's 2 plus, and I is 1 minus, so this would be Bai2, and barium iodide. Nitrogen and cesium. Cesium is the metal, so CS1 plus and N3 minus gives me CS3N, and it would be cesium nitride. And sodium is Na plus, and hydrogen is positive if it's with a nonmetal, but negative if it's with a metal. So this is going to be H1 minus, and the charges are balanced at NaH. And we would call this sodium, I'm going to follow the same rule, hydride. Okay? If these were a challenge for you, be really careful as you do the practice. Let's bump it up a little bit and practice monatomic ions that need Roman numerals. So remember that the Roman numeral tells you the charge, and now we're going to go back and forth between names and formulas. So lead 4 oxide, this Roman numeral of 4 tells me that the charge on the lead is 4 plus. Oxide tells me that it's oxygen, and from the periodic table I can see that its charge is 2 minus, and they are not balanced, so this would be PbO2. Cu2S, I need to figure out the charge. This is going to be copper. And I need to figure out the charge so that I can put the Roman numeral in there. This is sulfide. And to figure out the charge, I need to know that S is 2 minus. And since I have 2 Cu's to go with it, this has to be a total of 2 plus, but that total charge of 2 plus divided by 2 would give me 1 plus for each. So the Roman numeral in here is copper 1 sulfide. This takes a little bit of practice. If you're struggling with that, pay really close attention. FeBr2, we're going to do the same thing. Fe is iron. Iron needs a Roman numeral because it's in not one of those 4 that I'm supposed to memorize. And bromine becomes bromide. And let's figure out the charge. FeBr2, the Br is 1 minus each times 2. That makes negative 2. That means this has to be positive 2, and there's only one of them. So this is iron 2 bromide. Finally, mercury 2 chloride. Mercury 1 is a weird polyatomic ion, but mercury 2 is just like everything else. So the 2 tells me the charge. Chloride from the periodic table is 1 minus. So this equals HgCl2. Okay, again, you stop the video, try the next 4, and then write them in your notes, write them in your learning targets as examples, try them, and then turn the video back on so that you can check your answers. Okay, copper 2 nitride is going to be Cu2 plus. Nitride from the periodic table is N3 minus. This means I'm going to have Cu3N2 as the formula. PbI2, this is lead. Lead needs a Roman numeral. Iodide. Iodide is 1 minus each. There's 2 of them, so this means the charge on my lead is 2 plus. Chromium 3 sulfide would be Cr3 plus, and sulfide from the periodic table is 2 minus, so this gives me Cr2s3. And FeO, this is iron. Again, iron needs a Roman numeral. Oxide. Oxide's charge is 2 minus, so this means that the iron is 2 plus. Hopefully those went well. You'll get more chance to practice. All right, so let's do some hydrates, and then we'll come back and see if we can find errors in things. Okay. Oh, I missed this. Cupric nitrate trihydrate. I need to fix this. So we're going to say copper 2 nitrate, okay, and the trihydrate. So you don't need to know cupric is copper 2, but this is copper 2 nitrate trihydrate. So I'm going to do Cu2 plus nitrate polyatomic ion, NO3 1 minus. I need 2 nitrates, which will be Cu parentheses NO3 2. Trihydrate means dot 3H2O. Zinc hydroxide. Zinc is Zn2 plus. You should know that one. Hydroxide is OH1 minus. The charges are not balanced. I need 2 hydroxides. So I need to put the hydroxides in parentheses. This is going to be a place you make a mistake if you're not careful. Lithium is Li is lithium. And Cn is the polyatomic ion cyanide. Lithium does not need a Roman numeral. Stop the video, try these 3, and then restart the video. Make sure you copy the examples into your notes. Okay, here goes. Ammonium is NH4 plus. Sulfate is SO4 2 minus. This means I need 2 ammonium. So I'm going to put it in parentheses, and 1 sulfate. This next example is nickel. Nickel needs a Roman numeral. I'll figure it out in a second. NO3 is nitrate. And the 6 water is going to be 6 for hexa for 6, hydrate. And now I need to figure out the charge. So nitrate is 1 minus times 2, that's -2. I have 1 nickel, so that's +2, nickel 2 nitrate hexahydrate. And finally, potassium bicarbonate is K1 plus. This is the polyatomic ion HCO3 1 minus. The charges match, so that's just KHCO3. Okay, so we're down to trying to figure out errors and do some practice. I would really like you to do this on your own and then come back and check. So I'm going to do the first 3 in a second and then ask you to do the second 3 also. But stop the video first, copy them into your notes, stop the video, and practice first. Stop now. Okay, let's do the first 3. Ammonium phosphate. The easiest way to figure this out is to go, okay, what would be the real formula? So ammonium is NH4 1 plus and phosphate is PO4 3 minus, which means that somebody reversed these 2 numbers, right? So this should be NH4 3 PO4. Aluminum hydroxide, aluminum is 3 plus, hydroxide is 1 minus. So they balanced the charges, but they forgot parentheses. Okay, it should be AlOH3, parentheses 3. A few mistakes in this next one. Mg is magnesium. Magnesium does not then need a Roman numeral, and HCO3 is not carbonate. HCO3 is bicarbonate. The charges are okay. Magnesium would be 2+, and bicarbonate would be 1-, so the formula is correctly written. Okay, stop the video again, try the next 3, and then restart it. All right, I'm going to go ahead and answer these for you and see how you did. Chromium, this is chromium. This is not nitride. This is nitrate. This is the polyatomic ion. And if it were chromium 3 nitrate, it would be Cr3+, NO3 1-. So the formula is correct for chromium 3 nitrate. Ca, NO2 twice. Ca is not cadmium, it's calcium. And NO2 is not nitrate, it's nitrite. Okay, so if you're going to correct this, then you should have calcium nitrite. And calcium does not get a Roman numeral, so it's just calcium nitrite. Potassium chlorate, potassium is not P, potassium is K, 1+. Chlorate, this is perchlorate, so chlorate would be ClO3 1-. And because I don't need more than one of the chlorate, it does not need parentheses. All right, you get lots more opportunity to practice this as you go through the practice problems from the textbook. Be really careful and make a list of questions if you have them so that we can discuss it when we get back to class.